If I asked you, how important is water to your daily routine, what would you say?
Would you agree that water is an often overlooked essential element of sustaining our life?
But how much do you know, really know, about the water that you're using?
What if I told you there's a chemical invading our water supply? Would you be worried?
Scared?
Nervous? Think it can't happen? It is.
Across the country, throughout our state,
And right here in the city of Marshfield. The chemical is chloride.
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 Chloride, and we're the ones putting it into our water supply.
Today I'm going to tell you about chloride.
What it is, where it comes from, and how it impacts our health and our environment.
I'll also tell you about how you can have an impact on reducing the amount of chloride that is slowly leaching into our water supply. Where does the salt go? On one hand, it can run off and infiltrate into the groundwater and end up in your private or municipal well. Or it can run off and go directly to streams. And in this case, the graphic in the lower right-hand corner is a picture of the Yellow River as it's flowing strongly through the spring thaw melt. When it leaches into the groundwater, you can see where it starts up into the pavement area by your homes, infiltrates your groundwater, and can move as a plume into your neighbor's well, a municipal well, or actually infiltrate into the stream. Rolled salts and water softeners dissolve salts into an exchange of ions that includes about 40% sodium ions and 60% chloride ions, and make their way into the environment. This has a negative impact on both your health and the overall environment. It's going to be difficult and costly to remove. There are ways mechanically that you can remove chlorides, but we'll talk about later that their carbon footprint and energy of the cost of those methods are very extreme. There are alternatives available that we'll discuss, such as exchanging water softeners or different ways of de-icing applications. What we're really going to talk about here today is an ounce of prevention is worth a pound of cure. That if we can take the methods now to save our environment later, we will save ourselves billions of dollars. Sodium contamination in the drinking water is a concern for people that have hypertension. The additional sodium will increase their chances of stroke, dementia, heart failure, or even kidney damage. Chloride ionized in the water will stimulate pipe corrosion. This corrosion effect will also affect your health by digestion of heavy metals. And we'll discuss pipe corrosion later on to show you how those heavy metals will get into the drinking water.
Why is it good to keep sodium out of the groundwater? Because it raises my blood pressure, which gets really high, and it rusts my car, and it does bad things inside my water pipe. Thank you.
The transport of sodium in the environment also alters soil conditions. The sodium will replace itself with other chemicals in the ground, such as magnesium or potassium, and those will then leach into the ground or surface waters. You can see from the graphic the different levels of contamination chlorides and sodium have and are limited by either the US EPA or the Wisconsin DNR. A couple of ones to point out are the toxicity level of surface water. Right now that's at 394 milligrams per liter. The acute toxicity, where it kills instantly, is 757 milligrams per liter. And just for knowing, the sodium level is 20 milligrams per liter. And the secondary drinking water standard, which is an aesthetic standard where people will actually notice the taste of chlorides in the water, is at 250 milligrams per liter. Road salts also have an impact on the environment. Road salt contains an additive such as ferrocyanide. It's an anti-caking compound. This allows the road salt to be spread on the roadways in individual granules rather than big clumps. This ferrocyanide, when exposed to sunlight, will release cyanide ions into the drinking water, and cyanide, even at low doses, can be extremely lethal. This also increases the nutrient concentration in the water, This limits the ability of water to act as a buffer acid deposition, and this can impact both the wildlife and the taste of your water. For animals and humans alike, the US EPA has listed chloride as a toxic pollutant due to these reasons.
Lake levels are seeing chlorides increase by factors of 3 and 4 times, and we're seeing that in groundwater. It's starting to affect the health of the lakes, affect the plants, the animals, the fish, and we're seeing it affect the drinkability of the groundwater.
The infrastructure impact it has starts with corrosion in the pipework. You can see on the graphic on the left where the iron Fe2+ ions are moving from points of high energy to points of low energy. Also, they show where the copper 2+ ions do the same thing. You can see how they cake in the middle and they actually restrict the joint area. This decreases the pipe diameter and it really increases the amount of friction loss in pipework, so your airflows are decreased considerably. This also, as these ions are traveling in the drinking water, they get moved and you can actually drink them as they are soluble in the water, and this can lead to heavy metal poisoning such as lead poisoning or other heavy metals. And anybody that grew up in the 60s knows about lead poisoning in paint. Well, this is a similar thing, as in the 60s they put a lot of lead services in the ground, so we now have exposure to lead on a regular basis with this pipe corrosion going on.
I've been working with the Marshfield utilities on lead and copper control in drinking water. And there is a relationship between the chloride that's found in groundwater and the release of lead and copper from pipes in the drinking water system. Chloride forms a highly soluble compound with lead, but particularly with copper, and that's how the copper, one way that the copper gets released from the pipes and into the drinking water.
It also infects your infrastructure from an automobile standpoint and a transportation standpoint. The figure on the left is your standard car that's been operated in northern climates where they use salt. You can see the corrosion taking place on the door here. And you also see on the graphic on the right is a pavement joint area where the salt has accumulated in the joints and caused the concrete to spall. This corrosion impact is estimated to be $16 to $19 billion a year in the United States. Our current roadway salt application over the years has increased dramatically. You can see by the graph on the left as the increase in tons per applied overall has increased at an exponential level. And some maybe explain this by the amount of roadways have increased over time. But the graphic on the right shows that the city of Madison has increased their salt application per roadway lane mile, which doesn't have any effect on the number of roads. It has the effect on how much salt is applied for every traffic lane per mile. You can see that that's almost a linear progression since about 1979. In the early 70s, they had gone through a salt limiting study and they were decreasing their salt application. But since that time now, they have steadily increased at a linear basis to now where it's up into the 12 tons per mile range. That is dangerously scary in my book. You can see from this graph, this is the city of Marshfield's wastewater influent and effluent tracking over the last calendar year. The bluish gray line is the water that's coming into the treatment plant. You can see it goes from at a low point of 200 milligrams back in the beginning to now it's about 340 milligrams per liter. And you can see that the effluent is a little bit higher. That is because the wastewater plant has to add a ferric chloride to get rid of some nutrients in the wastewater to help meet their DNR permits, hence the increase. But whether it's the influent or the effluent, you can see that there are both considerably above the 250 milligrams per liter standard in surface waters. You can see on their average from 2011 and 2012, they averaged 310 and 350 milligrams per liter. And again, this is considerably above the surface water measurement of 250. In relation, Marshfield Utilities produces water that contains about 83 milligrams per liter on average, and you can see that line is represented by the blue line near the bottom of the scale. Some solutions for removal. There is no natural process for removal of chlorides. It cannot be metabolized or eaten up by vegetation. So you have to look at some other items such as reverse osmosis, distillation, or deionization. The graphic on the lower left-hand corner is a large osmosis plant, and the graphic on the right is a distillation plant in Upper Norway. One solution can be reverse osmosis. Reverse osmosis is the process of forcing water through a membrane to take out contaminants. The one problem with this, though, is it doesn't remove anything like viruses or bacteria, so you'd have to do some sort of disinfection process anyway. It's also not practical for high volumes of water. One thing we can all relate to in this area is the production of maple syrup. A local maple syrup provider, at a cost of $15,000, has installed a reverse osmosis system. It's a two-membrane system. It can process approximately 1,500 gallons of sap per day. In relationship to that, Marshfield Utilities produces 2.1 million gallons per day. This is a huge difference. At a cost of 10 to 1 for the maple syrup system, that would cost Marshfield Utilities approximately $21 million for that system. That is an unimaginable amount to provide to your users for an increased cost. Another solution is distillation. This is really only good for small amounts of production. However, in some areas they do large amounts, like Dubai. The graphic on the bottom of the screen is from Dubai. It's a desalination plant. Look how big it is and how many smokestacks are coming out of it. The energy production for distillation is huge, and the carbon footprint is such that it's unimaginable. It can only remove the salt, but it won't remove any organic matters or any carbon-based matter. So you have to have another filtration system for that. And it's really only good for a few gallons per day. And as I said, it's a huge carbon footprint. A third solution is deionization. But this adds dangerous acid and base chemicals to your water, which is a concern for everybody. It does not remove any organic contaminants, and it does not remove viruses or bacteria as well. So again, you'd have to have a disinfection process. It requires high amount of electricity, again, which these costs are going to be passed on to your utility consumers. So what's our best choice? Prevention. A small amount of prevention early on can help prevent huge costs down the road.
Chlorides in the water is a rising issue, and the reason it's mainly important for wastewater is the water that flows through the city ends up down at wastewater, and we have to treat what we can, and the rest goes out into Mill Creek. If the chloride levels coming to the plant are elevated, we have no way of getting the chlorides out, thus they end up in Mill Creek, farther down into the Wisconsin River.
Some things that we can do for residential prevention is dealing with our water softener chlorides. One thing a person should consider is doing a portable exchange water softener. That is a situation where somebody like Culligan would come provide a water softener to you, and when it gets filled up, it would exchange it for a newer model, and then they would take care of the disposal. Or we could upgrade to a water softener that is a newer model with an on-demand setting, so it will only be treating water as it processes through it. And we want to make sure to set your water softener to the proper level of treatment. In Marshfield, we recommend that you set it at a setting of 15 grains per gallon. From a de-icing perspective as a resident, there's a couple of things we can do. You want to apply de-icers early but sparingly. Extra salt does not make the water melt any faster. How many times have you been walking down the sidewalk or a driveway or a parking lot and you walked across salt that's been spread and there is no snow or ice to be seen? Well, that's because the ice has already been melted, yet their salt still remains. Well, this is salt that's been used in overabundance and is just going to waste and is going to get into your drinking water or storm sewer system. Do not de-ice with items like kitty litter, ashes, or any other product containing urea, as these chemicals can be much more harmful to the environment than chlorides can. From a commercial prevention standpoint, there's a couple of things we can do from a de-icer. You can pre-wet your rock salt before road application. The city of Marshfield has done that. They use a system containing 85% liquid sodium chloride, 7% magnesium chloride, and 8% beet juice at a rate of 8 gallons per ton of rock salt. This has decreased their de-icing range from 15 degrees to a negative 10 degrees, which is a huge difference. It also limits the bounce effect. How many people have been behind a snowplow that's distributing salt and watched it spin off the back end and bounce all the way to the road ditch? Well, why would we be salting the road ditch? Nobody travels there. Again, this is just wasted salt that's getting into our drinking water. It also promotes residual melting as the liquid stays on the pavement and promotes melting later on down the line. It also uses 30% less salt over a season, and this is directly translating into dollars, both from a material standpoint and a manpower standpoint. It has saved the city of Marshfield $73,500 in salt and an additional $92,000 in manpower alone. This money then can be used in other areas for the city and provide better services elsewhere. From a commercial perspective, there's a couple of things you can do. Consider other methods of payment other than pounds of salt applied. In our research for this project, that was one of the astonishing things we came out with. A lot of the providers pay their contractors on pounds per application. Well, if it takes 10 pounds of salt to do the job on a parking lot, what's to stop the contractor from producing 11 or 12 or 20? This is wasted salt. It's not going to be needed, but he's getting paid for it, so it doesn't matter for him. So we should really consider paying per application, per hour service, or something along that line to make it more economically feasible for him to do what's right rather than over-provide. As a commercial person, you should also investigate new technologies or application methods in the future. One of the latest ones that's come out is actually placing cheese brine, which is kind of like the liquid application that we talked about with the city of Marshfield, only to the next level. It's taking a waste product, which places are trying to get rid of. They're purchasing it, using it for de-icer. Many counties in Wisconsin are already doing this, and it's working for them quite well. So, from a solution standpoint though, the best solution is prevention, prevention, prevention. If we can do an ounce of prevention now, it's going to save us billions of dollars in the future, and that's really a good thing. I want you to evaluate your application methods so that you're doing what's good for the environment, yet doing what's necessary to de-ice your areas. Evaluate your payment methods so that you're not paying per pounds of salt applied. This does not encourage good use of the salt at all. Investigate your water softener settings, locations, and your years of service for that softener. Make sure you have a newer model that's more energy efficient. As time goes on, also keep researching new methods and technologies out there from both a water softener standpoint and a de-icing standpoint. Remember that chlorides affect you, your business, your consumers, the environment. It also affects your wildlife, pets, you, and your children.